This lesson is on Chapter 4, Section 3, Conics. If you guys would open up your textbooks to page 329, we'll get this one rolling. We're actually only going to look at the first half of Section 3 today. We're going to primarily be reviewing circles and then also taking a look at our parabolas that are in this section. We will save ellipses and hyperbolas for tomorrow. So a couple of quick vocab words. A conic itself is the intersection of a plane and a double napped cone. Those are going to be hourglass shaped kind of sort of cone figures. If you look on page 329, you'll see a bunch of those there. And you'll also see where that plane intersects that double napped cone and gives us these conics that we're going to be studying. Okay, so that top row, the circle, the ellipse, the parabola, and the hyperbola, you can see where those are going to come from with these intersections. A locus, you're going to hear that word from time to time. It simply means a collection of points. All right, so a quick review of our circle stuff. We studied these earlier in the course, so it's not really mentioned other than at the very, very bottom of page 329. They give you that quick explanation or equation of a circle, but don't do any examples or anything. So I thought I would do a couple here just to freshen you up a bit. So standard form, remember, was x minus h squared plus y minus k squared is equal to r squared, h and k being the center, and r being the radius. So if we were to look at identifying the center of a circle, we would look at the numbers that go inside the parenthesis there with h or with x and y, and remember that those are our h's and k's. So we have a 2 in with the x and a negative 4 in here with the y. In order to have that plus 2 in with x, remember that the h value must be a negative 2. And to have a 4 in there with the y, or that 4 behind the minus sign with the y, it must have just been a 4 stuck in there. The constant at the end, remember, in standard form is the square of the radius. So the radius on this one, if there's a 9 back there, must have been a 3. Now what if we were given our center and radius and we had to come up with that equation? Well, if the center is at the origin, h and k are both zeros, so you don't end up seeing numbers attached to x and y at all. So the equation of this circle is simply going to look, when you could do it like this, I suppose, if you wanted to. Or more often than not, you're just going to see this. Okay, if the center was at 3 and negative 1 and the radius was 5, okay, this is h, remember, this is k. So if we slip a 3 in, we'll have x minus 3 in the first parenthesis. If we put a negative 1, we're actually going to have a y plus 1 because minus a minus is plus. Whoops. Come back here. That should be a 2, not a 3. Sorry, I saw the 3 right above it and wrote that instead. And then our r squared would make a 25. So x minus 3 squared plus y plus 1 squared is equal to 25. Okay, so just a couple quick review there. If you have more questions about circles, by all means ask. We have also studied parabolas to a certain extent. We're going to study them obviously a little bit more in depth now. A few reference points that you need to be aware of, and a couple of them you're already going to recognize. We need to be able to identify and find the vertex. A directrix, you may recall that term from past years in Algebra 2. The focus, and also the axis of the parabola. In other words, it's called the axis of symmetry. So that, again, has been in our very recent past. So it's pretty much the directrix and focus that we need to make sure that we identify and understand. So I went and I found a couple of pictures for you. These are different kinds, and for right now, not so much the equation is what I want you to focus on is the picture. Notice in this first one here, we know what our parabola is. Okay, so we can see that general shape. I want you to right now pay special attention to where the focus is and where the directrix line is. Okay, so we'll be talking about this a lot more, but notice that the distance from the vertex to the focus and the distance from the vertex to that directrix line, they are identical. Okay, so if we know how far the focus is inside of our parabola, the directrix line is going to be that far behind it. All right, if our parabola is tipped on its side like these ones on the bottom are, those focuses and directrix are still found in the same place. Okay, so if you identify the vertex and you know that, and there are ways that we can find our focus, and we'll be talking about that. But once you've found the focus, you know how far apart those two are, the vertex is and the focus is. The directrix has to be on the opposite side of the vertex, the same distance away. Okay, so that's the main thing I want you to take away from this picture. Notice that directrix is a line. So when you're stating the directrix, don't put down just a number. It's going to be an x equals number or a y equals number, depending upon whether or not that directrix is a horizontal or vertical line. Standard equation of a parabola. Okay. In section 4 of this chapter, we're going to be working with these more. Section 3 right now is going to have our center always be at the origin. Okay, so these equations are going to be similar in the future, but they're going to grow and morph just a tad bit. So that's why I'm splitting today into 2 days, hopefully to get you comfortable enough with this standard form with the vertexes and centers at 0. And that will help when we grow into ones that have moved. You'll still be okay with them. All right, so anyway, parabolas with a vertical axis of symmetry and a vertex of 0, 0. In other words, these are going to be the ones that open up and down. We already have worked with parabolas that have an x squared value. We know that they are the ones that open up and down, so that has not changed. Now the rest of the stuff on the other side, 4py. Okay, p is important to us now because in the standard form of the parabolas written this way, P is going to help you identify your focus and your directrix. Okay, so we're going to be rewriting any parabolas that we get into this form. So whatever coefficient y has, we want to rewrite it as 4 times another number rather than maybe a single digit that it starts out. If parabolas have a horizontal axis, I'm on number 2 now, still with a vertex at 0, 0. Those are the ones that had the y squared in them. Okay, so those are the ones that opened either left or right. Okay, so these were the parabolas that have the y squared in it. These were the parabolas that had the x squared in it. Okay, so now in this case, P is going to still help us find that focus, but the directrix this time is going to be a vertical line, so you're going to have an x equals negative P line. Now, finding that standard form. All right, if you are given the focus, 0 and a number, okay, so handing you the focus, you know then that that focus is going to be that distance from the vertex. You're going to put P, okay, so whatever that number is paired with your 0 is your P, put it back into that standard form, x squared equals 4px. Actually, that should be 4py. This one should be 4px. Sorry about that, I just caught that now. I'll have to go back and retype that slide. So x squared is equal to 4py. If you're given the focus p0, okay, so a number and then 0, we know that that focus is going to be on the x-axis somewhere, and therefore it has to be a y squared equals 4px equation. Okay, so let me try to diagram this a little bit. You're given a focus of 0p, okay? If that was like 0, 3, let's just pretend, would everybody agree that 0, 3 is right here? If that's the focus, and that's inside my parabola would either have to open up or open down with that inside it. Okay, so if that's the case, I know I have to be looking at the x squared version of my parabola. Okay, coming down here, let's say that we have 3, 0 as the focus given to us. All right, well 3, 0 is here. Now if that's inside my parabola, that means it must be a right opening or a left opening parabola in order for that to be inside it, and then I know I have to be using my y squared version. Okay, so hopefully maybe that little diagram helps you understand what we're trying to type up in this slide. Some of you like a lot of steps to guide you as you get used to doing these problems. So if you're going to find the focus and the directrix of a parabola, Rewrite the function by isolating the squared term on the left side. Now you're either going to end up with a y squared in there or an x squared in there. Again, that's flat out going to tell you whether or not your parabola opens up and down or whether it opens left to right. Rewrite the number part on the right side as the product of 4 and something. Okay, so the number part has to be 4 times something. Number 3, the amount that was multiplied with the 4 is p. Okay, some of that will become very much more obvious as we do an example together. The focus of the parabola is 0p if they open up or down, p0 if it's a parabola that opens left or right. Again, that's going to be based on whether or not you had an x squared or a y squared equation. The directrix of the parabola is either x equals negative p or y equals negative p, again, depending on if it was left, left, right, or up, down. Let's practice. Find the focus and the directrix of this parabola. All right, so the first thing we want to do is isolate the squared value. So if we're starting out with y is equal to 1/4 x squared, we want to get that 1/4 off of there. So we're going to multiply both sides by 4, and I'm going to rewrite it so my x squared comes first. Okay, so if we multiply both sides by 4, we have a 4y, and then of course my fraction is gone. So x squared equals 4y. Now here's the number part that we want to rewrite as the product of 4 and a number. So because the number is a 4, I would rewrite that as the product of 4 and 1. I would still have 4. Here is p. Okay, so my p value on this one is going to be x squared, or a 1. Okay, so if I have an x squared one, I know I'm going to be opening either up or down. In looking at this one, I know it's going to open up because I have a positive value, not a negative. We know that from our reflections from chapter 2. My vertex is still 0, 0. Now if my focus is going to be the point, okay, so focus now, I'm going to use that p value to come up with this point. My focus is going to be 0p, right, from our previous slides. So 0, 1 is that focus point, which means if my focus is 1 up from my vertex, my directrix must be 1 down. So my directrix is going to be this line. Okay, so now you need to come up with the equation of that line. That would be the line y equals -1. Remember how that previous slide said the directrix was going to be equal to y equals -p? Well, there you can see it put into play from our diagram. Okay, then sketching it, do a table of values for your equation like you always would. Okay, so if we had x squared is equal to 4y, you can see the 0, 0 vertex that we already knew. If I put in a 1, I'm going to have 1/4. If I put in a 2, I would end up with 1. If I put in a -2, I'm going to also end up with 1. And frankly, if I put in a -1, I get the 1/4 as well. Remember, they're symmetrical. So all you need is a couple of points to give you the gist of your curve. All right, so to label a few things on here, this, of course, was the directrix. This point here, focus, and of course the red curve is the parabola itself. Okay. I truly want you to work on these parabolas before we go on to ellipses. So the second half is going to be a little bit bigger than the first half. But would you guys please turn to page 339 with me right now? The ones that deal with the parabola are going to be ones, let's see how far we can go. I would start somewhere around number 17. Anything from 17 even through the application problem 31. Okay, play around with a bunch of these. Um, and we'll come to class and we'll do a bunch of these practices in class tomorrow, and then we're going to move on to the ellipses and the hyperbolas. I kept those two together, and you'll see the similarities between them tomorrow. But circle ones, you might have to go back in the book if you want to play around with some circles a little bit more, and I encourage you to do so because they do expect that you're going to do that in this section for some reason, even without a review. So don't neglect the circles. Parabolas are your focus for tonight.